my friends, good morning. Enjoying a nice warm cup of coffee and looking over my sled on my table saw. And I think some of you, I know some of you are interested on making a sled. And there's so many variations of sleds out there. They all pretty much do the same thing. The only difference from one to another is one might be fixed at this particular angle, or one has a movable fence, which is, they're all fine. They all work well. It's just you applying yourself to it and putting it together, starting off that it's true, and everything else is true for you for that sled. There are very simple sleds out there that the end results are the same as this, regardless of how complex it is. But there is a lot of functions on this that you don't see on any sled. On any sled. I wanted a sled that I could run on my table saw. It's running on two rails. I got this rail and this rail. I wanted to make sure that it was very true in a sense that I have no wobble whatsoever, yet it glides nicely. So there's videos out there that you can go to and see the best way for you to make these channels, making sure that they're nice and tight. They can move, but there's no flop whatsoever on them, and set up your table on the top of it. Okay, the construction. Nice flat piece of wood. I attached a fence, glued in place to the back of it, flat with the back part, glued it in place, and I actually just nailed it in. Finished nails going through it. I drilled and nailed the rest of the way into a poplar fence. This back part is poplar. It was nice and true. Then I made an L-shaped channel rail. As you see, again poplar. A 1.5 by 1.5 back. Put it together with the glue again, so I ended up with this L-shaped. Cut it more or less to 20 inches. It doesn't have to go all the way out, but it can go all the way out. It doesn't matter. I wanted to end it up just a little bit short on this end, so I could do a gauge, a miter gauge, going through the whole length of the board. And this is not made for 45s. It's only made up to a 30 degrees. I cannot see making any rings with anything over 20, which is an 22.5, which is 8 segments. So, but I have it in there up to 30 degrees, just in the event that I ever wanted to do anything different. The fence, once I made the base with these channels, I ran this through the table saw and I cut it up to this point right here, just back here. When that was done, I drilled my rail where I wanted it. It doesn't have to be here, as long as you have room. As long as you have room to go as far as you can and not bottom out somewhere else. So, really, that's all I need. It goes up to the 30, and I got clearance here. So, I concentrated on that, and just before, at a point, see if I can bring you in there. Once I had the table, had the notch, had my fence made up. On this side back here, on the flat part, I drilled a 1/4 inch hole about 3/8 of an inch back from the slot that the saw slot that was cut by my my blade. Drilled it straight down. Countersunk the back of that hole and put a bolt going through. Yes, by the way, when I put that bolt through, I'm trying to think of how I locked it up in place. But anyway, you can do it with just a nut on the top. Just make sure that whatever you put here does not get in the way of this curve that you've cut. You are cleared away from that. There's no way that my sled will ever hit metal over here. It's clearly to the right of that, and that becomes my pivot point for my fence. This part over here, the slide and where the fence rides on, was actually after the fact that I did. So if you look, you see that I have holes going through the rail at different points. The idea for these holes, okay, were that if I put a dowel, if I put a screw that would be the correct size for that hole, or the drill bit for that matter, and I wanted to make an 8-segment ring, I would just bring this up, and once that pin would fall down, I would be there. What I found is that it gave me a little bit of play on it, and it was locking me up to a set that might not be 100% true. Oh, my modifications took it off. So you can do this system if you drill precisely. Once you get your angle and you do your holes and they're nice and tight and no play whatsoever on it, and you want to do this type of an action, you can do that, and that works without this. But because it didn't work for me, and so basically at this point we have a fence that can rotate on your table. I like this idea. To achieve this radius that I wanted here, the way I did it, okay, is I made a hole through the fence and the tabletop. Took my drill through that hole, and I just made a whole bunch of different holes going through to the point that I felt that I had all the angles that I was going to need. And then with the drill running in there, I actually cleared it up by forcing the fence, going with the drill running back and forth, and it gave me this slot. It's not the prettiest slot. You can do this with a router, which would work a lot cleaner, as long as you can put it at your radius point, its location. Bring your router down and zip it like a compass. That will work for you. So on my case, that's what I did. And once I did that, the big thing that I did to this this piece that might make it somewhat different from anybody else's is I put down a lot of information on it. And it's information that I can come out here and set this up real quick to my angle, make my cuts, and I know I'm there. Now I can verify again with a protractor if I have any doubt whatsoever, but I already did the all these gauges with a protractor. So the only thing that I might be off is the thickness of the line, because the thickness of the line can impact your cut by a 1/10 of a degree, or half of 1/10, 1/20th of a degree, and you put a lot of segments together, and that's enough to throw you off just a little bit. And there's other variables that can throw you off, but that's just one of them. So because I made this specifically because I wanted to make compound bolts, compound angles. You're working with two angles at the same time. This being a 45-degree wall, this being, I know that the thing says 60, and I think that they take it away from a non-parallel, or they're going this way, and that's the only way that I can see that it would be a 60-degree. But anyway, whatever it is that I want to do with different compound bolts, the information is over here, and it's complicated. It's there isn't, I don't know of any formula without going to extreme mathematics on figuring out what the angles would be to duplicate this. Well, I know it's 8 segments, so you say, well, it's 8 segments, so this should be 22.5 degrees, right? It's not. Okay, it's not, because you are also working with a blade angle to give you this type of a pitch. So it's information that I did not have, or I could not calculate real quick. So I did a chart on here that shows me the most common of these that I will ever make. And I'm not going to get really elaborate with this. It's not going to be all of a sudden I'm going to make a 32 segment on one of these. It's nothing like that. I will make an 8, a 12, or up to a 16 segments to one of these. Very, very doubtful that I'll ever even make a 16, because when you're compounding, you are really compounding a problem. Not only your compounds, but you get to these, and they are very touchy on making sure that you end up with things that pull together. But anyway, what I did is I grouped it up into the top reading. Let me see if the lighting can get a little bit better, and maybe zoom you in. There we go. That's pretty good. Okay, there's 3 groups. It's split up by this white band in between. The first group is for 8 segments. Next group is for 12 segments. And the next group is for 16 segments. For these compounds. So the first group, I can do a 60-degree, 45, or 30. And that corresponds all the way down. 60-degree, 45, 30 to each one of the settings. And that degree is the pitch, the wall angle that you have on your segment that you make. This particular one, fairly shallow, was done with this top setting over here. It's an 8 segment at 60 degree. I set the blade at 11 degrees. Now, I still use the protractor. This is a cheap unit. If you're going to make one of these, you should have one of these. And then if you don't want to make it fancy like this, use this and put your fence at whatever angle you want based on this. I mean, this is, I think, $15, $20 on eBay, you know, and it's really a valuable tool if you're making rings. But anyway, back to this. If tomorrow I wanted to make this exact ring go bigger or smaller, you know, the size doesn't really change anything other than putting a stop where you need it to. But I would come over here and I would set this fence back up. I would set this fence back up to that mark right there. Lock it up. And my setup would be exactly to this again, which is 60, 11 degrees on the blade. I would have to set up the blade with a protractor. You can get one of those little magnetic ones that actually sit on the blade, and those are even better than this as far as for your blade set. But I wanted one that I could do it so I could come up with this formula. I wanted to go all the way from 90 and work each one of these degrees and mark them up and make my own scale on this up to 30 degrees. So it took me a little while, but I went 1, 2, 3 all the way down. When I got to 10, I stopped with this, and I actually took the compass and used the compass as a divider and worked it up, and I just went back. Let's say I set it up for 10, 20, 30. Then, because I already had these in between, so I would go to the number 1 and that would give me the 11, and so on and so forth. And I just did that for 10 with this, and the rest was with the divider, a compass. Wrote everything across the top, put the numbers that I know that needed it. You can get these off the internet, what you need for that formula. And if you don't, you can copy this. These formulas are correct. So 8 segments, 60 degrees is 11 on the blade, 19.7 on the miter. 45 is 15.7 on the blade, 16.3 on the miter, and so on and so forth. Pause it, copy it, and if you can't read it, send me a, I have on the computer the formula, so send me an email and I will gladly send you that sheet, that PDF sheet that you can use to get not the layout, but to get the formulas, only the formulas. So the stop corresponds to all my compounds, all my compound miters. And because I wanted this to be a sled for rings, not just compounds, I towards the bottom I did the same thing, but for just flat rings. 8 segment, 10 segment, 12 and 16. If I wanted to have more information over here, I could do this, break up another lines over here and go 16, 24, 32, whatever I wanted, and I would color code the bars. Of course, this would get pretty small over here, but I would do the same thing and follow it through. These are the ones I use most often. So if I come over here and I want to say, oh, today I want to do a vase, I want to do a bowl, I want to do whatever, it's going to be all 10 segments. I come over here, no guesswork, I set this up for 10 segments. It's the end of that red line. Lock it up. It's set for 10 segments. What's 10 segments? I don't care what the degree is. I got it marked, but it's written there as well. It's 18 degrees. If I really want to verify and make sure that that's the case, I can always put the protractor. I can always read my additional information that I have on the top, but I know that 10 segment is 18 degrees, and I set it up to that red mark right there, and I look at the top, it's set right at the edge of the red, that's where the 18, and I look at the top, whoops, sorry about that, but you can see the angle makes it look like it's off, but it's not off, trust me. Okay, 15, 16, 17, 18 degrees. I'm at 18 degrees up there as well. I'm referencing to that, and I'm referencing to this. Now, there's still, like I said, that thickness of the line can set you back by 1/10 of a degree. I also broke down a 1 degree in 9/10. As to break a 1 degree into tenths, and I don't use that. I don't use it because it's too minute. If I come up close, so in other words, if I need a 15.7 and I'm making cuts and I did my cuts at 15.6, you know what, that is close enough where I'm not going to be spending a lot of time and trying to get that exact 1/10 of a degree that I might be off. I will do that on the disc sander. So I can come up with all the different segments that I need. They're referenced right on the fence itself. Now this part right here, yes, I have that here. I don't use that. It's too touchy, because when we do on miters for rings, we are working with 1/10 of a degree. For instance, you got the 11 1/4, you have the 22.5, you have 10.7, 11.7, 16.3. These are all 1 degree split into tenths. So I have that information as well on my fence. Okay, I would bring the fence to the 15, and I would line up the first line over here exactly smack center with the 16 degree. It's still set on the 15, but the line over here, I'm niching it forward to line up with the 16. So if I want a 0.2, I would bring it forward, and the second line would line up with a 17, and so on and so forth, and until you would end up with 9/10, and you would be right back to the 16 degree as your next mark. So again, a little bit too much information for a fence or for a sled, but I have all the information on the sled at my fingertips. I really don't care how accurate you are with this or this. You're going to get slight variables. The reason why we have slight variables is because we are not working with steel. We're working with wood. And wood changes, it moves on you. So your blade temperature on how many cuts you make are enough to set you back that 1,000. So you can make a perfect ring right now and make another one back to back. One ring goes perfect without any touch-ups whatsoever. I've done this many times. I've done rings back to back, mount them together, I'll have a whole set, and no need to go to the disc sander and another set. There will be that minute, I mean it's minute, but it's not a totally closed gap all the way across, and I'll have to true it up in half rings on the disc sander. So that's what I do. That's how I approach and that's what I did for this particular segment jig for this sled. Oh yes, we need a stop. We need some way to set up a stop so you're consistent with the lengths of your segments. Well, drill the hole on the back of this. It's fixed. Put a bolt through it and picked up a wing nut. A piece of wood. I made a slot at the same height as my bolt and ran it on the router and cleaned it up. A little bit over the size of the bolt. You want to make sure that this slides nicely and it doesn't get hung up. Put a washer in between, and so that's my stop. I am not going to make any segments, a single piece segment that's over the slant. So I don't have to be bigger than that, and it goes in enough where I'm almost at zero. As a matter of fact, if this is at 90, it's cut at the same length as my my groove on my sled. Lock it in place, bring the material to it, it's going to be on every time. So, going to make an 8-segment ring. The first cut is just taken off enough to, because it's waist, establish your angle. Let me get some of this stuff out of the way. So let me make these few cuts real quick. Here's my 8 segments. I got a lot of fuzzies on this, and like I said, the only thing I will do to this is knock off those fuzzies. So right behind me I have an old disc from my disc sander, and I just run it and knock them off. It's a little coarser than what I need. Basically, I'm just breaking them off. I'm not modifying my angle. My angle is staying exactly what it was. And I'm not even getting them off 100%. I am just making sure they're not in my way. That's the only thing I'm doing, is popping them out. But if I change my blade and put a nice sharp blade over there, it's going to eliminate all of this, or almost all of this. So here's the 8 segments. I still have some fuzzies on it, but they're not troublesome. They're not going to be in my way. My cut is smooth, and that's really the only area that I have to worry about, is the cut. When gluing them together, I generally do it on a surface, in this case melamine, that the glue is not going to stick to it. I can scrape it off and bring it right back. So I have the 8 segments. Let's see how we did for measurement. Put them together. And for the seams. Oh, I got a little fuzzy that got in my way over there, but let's see that. Now don't mind me, but I want to also show you some other option with rings. That's really easy to do, and it's another option that you have when you're working with these, and it's an option that I use quite a bit. But you can see that my ring doesn't look all that bad. I mean, I'm not clamped up, but if I put a clamp on this, let me put this under pressure. I could actually just do it with tape, but that's not what I'm doing right now. And tape method is a good way of gluing them together as well. If you put a piece of tape upside down and stack up your segments on the tape itself with the skinny side up, you apply the glue in those things, close up the tape, and you get a nice circle. Now I'm not going to squeeze this in because I want to show you how far I'm off. So again, I just brought that fence to what I thought was pretty close, and the thickness of the line makes a difference. So I want to make sure that I'm tight on the outside edges. But you can look at this and say, wow, that's not bad right off the saw. But I know that I'm not dead on. I can see that little gap is a little wider on the inside than it is on the outside. So what that tells me is that when all said and done, I will only do this in halves and true up this little bit that I'm off on my disc sander. Now if I was going to make multiple of these right now, okay, this was the first one, but if I was going to make several, well, I don't want to be doing that every time. I would twitch this just a hair, okay, and bring this back just a little bit. I mean, you barely move it, and continue doing my rings. This is not wasted. It's close enough, definitely close enough to do what I wanted to do. And I would make that minute adjustment that you just saw, and I would continue, and I would just go ahead and, you know, maybe read through this cut, which there's nothing to take off really, but continue with my cuts and make another set for whatever amount I wanted. If I wanted it to be bigger, you know, I would. So if I was going to continue doing rings on this, I made that slight, you know, 1/10 of a degree, if that, adjustments to it, and continue making cuts. Put that one together, see how tight I was, dead on. Continue doing all, because I'm not changing the miters. I'm working on eight-sided all the way through, and just make all my rings that I need for any size bowl. Now, one thing that I do quite a bit is, oh, I wanted to see what size ring I ended up with. I'm sorry about that. 5 1/16 of an inch. Okay, so I was on a clamp, but 5 1/16 pi plus that 1/8 of an inch per run works pretty close to come up with what you want for your dimensions. Say you made a ring and you going to use it up for something that you definitely need a 5 1/4, and you just made a ring and it's 5 inches. You can make that ring better. Cut yourself some little 1/4 inch, 1/8, different slices of a contrasting color, and all of a sudden you made a plain ring into a nice ring. And sometimes I will do that. And do this sort of stuff. Now this was already made up. I had two outside pieces with a red in the center. I glued that up. It was a strip, yay long. Clamped it, glued it up, and whenever I needed it for a particular ring, I would just cut it up to the lengths that I needed and glue it up. Now here's a perfect example of a leftover from a ring that was, you know, a little oversized. Not because I mismeasured, but because I sometimes, especially with fancy rings, I will oversize purposely and part it out on my lathe, so I end up with another ring, just a slightly different size. So I will use this up somewhere else. You can see it's in an angle. It's the angle of the bowl that I was working with. I parted it out. This was the outside part of it. I save it. I put it aside. When making rings, one thing that I advise is that you maintain something set for you that's going to work for you all the time. Is don't mix and match how many segments you want per rings. So if you're going to make 20 rings and you don't even know what you're going to be doing them for, don't go ahead and cut 8 segments, 10 segments, 12 segments, 16 segments, because you can't mix and match when you're putting things together. The only time that you can mix and match is by doubling or half of the amount. So if you're using an 8, you can mix and match with a 16. You know, but you can't mix and match an 8 with a 12, a 10, or anything in between. So keep that in mind when you're making your extra rings. So if I wanted this ring to all of a sudden to be 5 1/4, not 5 inches, I would cut these on a bandsaw to length. It doesn't have to be exact, it's rough. And the height is a little bit over this. It doesn't matter because you're going to be facing this. But I will cut 8 of these slices, just zip them through the bandsaw, come out here and apply glue and put one of these in between each one of these segments, and all of a sudden the 5-inch ring becomes 5 1/4. If you want to end up bigger than that, and you take and you take some other wood or whatever and you glue these together, glue that together, leave it aside until it's completely dry, and all of a sudden you end up with, you know, contrasting woods. And again, once it's dry, you would cut it up to the length, you would add it to here, and all of a sudden you end up with a 9-inch ring or something like that, because you're adding quite a bit. So this is completely customizable, and you do what you want with it to establish. So that would be a little closer to the one that I just showed you. This is a little over the sizes that I used, but you get the idea. And you would make all the different pieces. If you take 2 pieces, for instance, like this, and you got a dark wood and a light wood, and one side thick, one side thin, you know, you can make an alternating ring where once you do it. Okay. So if you do something like this, where you have a wide one and a skinny one, and you cut your segments, when you put them together, you can alternate it, and you have a staggered small one on the bottom, big one on the top, then big one on the bottom, little one on the top, and that gives you a nice zigzag effect going through your segment. You can do one ring by itself just out of something like this. Now, it's the possibilities are really endless, and there are so many great wood turners out there that offer you so many options that you can put together and come up with your very own. Again, you know, we don't have to go fancy. It's what I was trying to achieve at the time when I made this one. There are very simple sleds out there that the end results are the same as this, regardless of how complex it is.